Hello everyone, my name is Dan the Tutor. This is a clip from one of my weekly group tutoring sessions at the University of Delaware for Physics 201. If you have any questions, please leave them in the comments below. Thank you and enjoy.
So that's it for work and energy. The last thing we're going to talk about today, we're going to wrap up with momentum. You know what they say, momentum, mo problems. If you want to write that down, it's a very good note. Okay, so how do we deal with momentum problems? First of all, how do we know we're dealing with momentum problems? Again, we're talking about collisions and explosions. Very cool things in physics, isn't it? Okay, so there's two kinds of momentum problems we can have. Momentum breaks up into two categories. We have conservation of momentum, and then we have impulse and momentum. Two very different problems. Let's talk about when each is used. I'm going to make like a T-chart here. So with conservation of momentum, the biggest thing you need to know is that we're only looking at it's two objects. If we're looking at two objects, then it's conservation of momentum. In other words, two blocks running into each other. Two cars running into each other, a meteor breaking up into multiple pieces. Those are all conservation of momentum problems. Impulse and momentum, on the other hand, is when we're only looking at one object. Sure, there might be multiple objects in the problem, but we're only talking about one of those objects. Some examples include hitting a baseball with a bat, and they only give you the information like velocity and mass about the baseball. They don't even tell you about the bat. Other common example, when you jump off of the earth. Technically, when you jump off of the earth, that's in a way an explosion because you're going up, which means the earth must be going down. But since the earth is going down, it's it's essentially zero. Like obviously you're going up, let's say 1 meter or whatever, but the earth is going down 0.00000000001 meters. We can ignore the earth and we're really just looking at the one object, which is you, the human. And in that case, we'd be looking at impulse and momentum. So again, how many objects are we talking about? That determines if it's conservation of momentum or impulse and momentum. Now, what's the difference between these two in terms of solving them? Equally important question. So for conservation of momentum, we're essentially saying this. P total initial equals P total final. Very reminiscent of E total 1 equals E total 2. Because it's almost the exact same thing. The only difference is we're talking about momentum and not energy. What is momentum P? Well, momentum P is equal to mass times velocity. And if I'm talking about P total, then I'm talking about mass times velocity 1 plus mass times velocity 2 plus however many objects I have. Most of the time it's just 2. Okay. And now that's it, what we're going to do for, again, conservation of momentum, which, how do you know if it's conservation of momentum? There's two or more objects that they talk about. And then for one object, we have this equation instead. Impulse, which uses the symbol J for no reason. I don't know why they chose this, but impulse is also known as J. This is not joules. This is impulse, capital J. And this is equal to, there's two equations we have. One is force times time. The other is delta P, change in momentum. Both of these equations work. However, I'm going to say this. I hate delta notation, so I'm actually going to rewrite delta P as P final minus P initial. Because, well, to me that makes more sense. And now the question becomes, well, which equation am I going to use on the test? Am I going to use force times time, or am I going to use PF minus PI? Great question. If they give you units of force and time, like they tell you 1,000 Newton force acting on an object for 0.2 seconds, you know what you're using. You're using force times time. However, if they give you mass and velocity, because remember, momentum is just mass times velocity, P equals M times V. If they give you a mass and velocity, you know you're talking about PF minus PI. You need to figure out which one you're talking about based on the information given in the question. And again, we'll talk about that today with a couple short examples. And yeah, that's pretty much it on the notes I have for momentum.
Don't forget to like and subscribe. If you want me to start doing free weekly group sessions at your university, please post in the comments below or email me at dan@danthetutor.com. Thanks everyone. Bye-bye.